Okay, now in this section we'll be continuing with our trunking protocols, trunking concepts, where we have seen trunking is a method of allowing the multiple VLAN traffic to go on the same link. So even though it is coming from different VLAN, but the trunk link is going to ensure that even though it is carrying VLAN 1, VLAN 2, VLAN 3 traffic, it will differentiate with some separate tag is added. And when it is sending any tag, any information, it is going to add the tag. And once it receives on the other side, it will remove the tag and it will send to the end devices as a normal frame. So that frame tagging is a method to ensure that even though they are going on the same link, it differentiates each and every VLAN traffic, and also it will notify the remote switch about the VLAN the VLAN membership to the remote switches. And this happens only on the trunk links, and this process is done by two protocols. Initially ISL, inter-switch link, which was a Cisco proprietary protocol. No more used, it's a legacy method, no more supported in most of the Cisco platforms. And the major disadvantage with this one is it is going to add 30 bytes of tag, which is going to add some extra overhead on the switches to add and remove the tag. And also it is a proprietary method of Cisco. So if you're using Cisco on both the sides, probably ISL is going to work. Now in today's networks, ISL is something not more supported, no more supported in most of the Cisco platforms, and even Cisco uses the default trunking protocol as .1Q. It's a .1Q, no, we write like this. It's a standard which works with Cisco as well as non-Cisco devices. It supports only Ethernet networks. Anyway, token ring, FDDI networks, they are no more used, so .1Q only supports Ethernet. And the major advantage is it's a standard, and also it's going to add just 4 bytes of tag information, which adds some less overhead on the switches to add or remove the tag. So in today's network, we just use only .1Q. Now if you want this trunking process to happen, like if you see here, I got a VLAN 10 users here, want to communicate with VLAN 10 users here. If I want these particular devices to talk to each other on different switches, in that case they should go from the link which is connecting between the switch. That's what we call as trunk link. Now the trunking will only work when you configure them with a trunk link. Like we need to go to the interface. Let's assume that I'm connecting port number 20. We need to go to the interface F0 by 20, and then we need to give this command called switch port mode trunk. Now once I give this command, we are saying to the switch that hello switch, this port number 20 is no more a normal port, it's a trunk port, and it is going to carry all the VLAN traffic. What it's going to do, it's going to carry all the VLAN traffic. It's going to receive the traffic from every VLAN. It can be a broadcast or unicast, and it's going to forward all the VLAN traffic, anything coming from VLAN 10 or VLAN 20, like that. And then we can define which encapsulation you want to use, whether you want to use .1Q or ISL. Now by default it runs .1Q. So if you're practicing this on a packet tracer, this command is not supported in some platforms, but anyway they use .1Q encapsulation by default. Okay, so let's go and verify in the command line some of the configuration commands. Okay, so let us verify the concept of trunking here. Now in this lab, I actually got some pre-configured topology here. I got two switches, switch 1 and switch 2. And this switch 1 and switch 2 are already connecting to port number 1 and port number 2 in the VLAN 10. And port number 3 and 4, these two ports are in the VLAN 20. And the same thing on the switch 2 as well. I got port number 1, port number 2 in the VLAN 10. And port number 3 and port number 4 in the VLAN 20. So I got exactly the same thing here. So if you just want to verify, we can go to the command line of the switch here. This is my switch 1. If I give show VLAN, you can see port number 1 and port number 2 in the VLAN 10. I already configured this. And port number 3 and port number 4 in the VLAN 10. Now you know how to shift the ports. If I just want to show you, you just need to say interface range F0 by 1 to 2, switch port mode access, switch port access VLAN 10, interface range F0 by 3 to 4, switch port mode access, switch port access VLAN 20. Done. So the same thing, it's already pre-configured. I'm just trying to do the same thing again. So the same thing you have on the switch 2 as well. If I give show VLAN, you can see port number 1 and port number 2 in the VLAN 10 and port number 3 and 4 in the VLAN 20. Now if I go to any one of this computer, and these computers are already pre-configured with some IP addresses, and I'm going to one of the PC IP config, and I'll try to ping to 192.168.1.1, the other PC, I'm able to get the reply. So here I'm trying to communicate with 1.1 and 1.2, these two computers, as they are on the same switch and they are in the same VLAN, so they can communicate with each other. Now let me try to ping to 1.3, which is on a different switch. Now in this scenario, I'm trying to ping from 1.2 and I'm trying to ping to 1.3. Now in order to communicate, they should be on the same VLAN. That's something already they are in the same VLAN. That's not a problem. And they should be on the same network. They are on the same network. But the third condition we need to match is there should be a trunk link configured. Because if they are on the same switch, there is no need of trunk link. They can communicate directly. But if they are on different switches, they should go via the backbone link which is connecting between the switches. And unless you configure the trunk link, this switch, it will not carry all the VLAN traffic, because the default it will be access. We need to tell that this link is a trunk link. So that's the reason you can see the request timed outs. It's not going. So let's go to the switch now to configure the trunk link. Now the same thing happens with these two VLAN also, VLAN 20, which is 192.168.2.1 network. So I'm going to connect port number 20, which is connecting between switch 1 and switch 2 here. I'm going to say switch port mode trunk. Now switch port trunk encapsulation command, it doesn't work in some of the platforms in this packet tracer here, so you don't need to worry. So just go to switch 2 and configure the same command, interface F0/20 switch port mode trunk. Now if you want to verify, we can use a command called show interface trunk. So when I give show interface trunk, it's going to tell how many ports you have at trunk ports and what is the mode it is on. That's a manual trunking, and what encapsulation we're using .1q and the status of that particular trunk link. And the number of VLANs will load. By default, this trunk link will load all the VLAN traffics by default. Okay. And if you try to ping now, after some time, now if I try to ping to 1.3, now you can see 1.3 is able to ping to each other. So if you want, you can go to some simulation mode in the packet tracer for verifying. I can click on this simulation and you can create a new scenario, and then you can capture some packets here. You can just generate a packet from here to here, and you can start forwarding. So the switch, it goes to the switch, and the switch will broadcast, and it goes. Now it is broadcasting first time because of the MAC entries. So I'm not really sure about this simulation, but it works fine. So if you try to go to this one of the PC, that is 2.1, because already we have a trunking here. So if you try to ping to the next PC, that is 192.168.2.2, which is on the same switch, 2.3, and then 2.4, you can communicate. So now always remember one thing, always whenever we configure anything, so always different departments, accounts, marketing, they're on different networks, different VLANs, different networks as well as different VLANs. Okay, so all the different VLANs should be in different networks so that they should not communicate with each other, and also they are in different VLANs so that they should not broadcast each other. So in order to forward the traffic from one VLAN, the same VLAN users, if they're on different switches, they should go from trunk link, and in order to do that, their trunking has to be manually configured with a command called show switch port mode trunk, and we can verify with show interface trunks.